is what operations are we using within the transformations? There's only 4 that we're going to use. Multiplication, addition, subtraction, and division. And so you need to identify a transformation that is happening consistently the whole time. Alright? And I'm going to write it out for the next one because we've already written it for this one. But the equation that we should have had for this transformed function is y equals 1/2 times x plus 4 cubed. Does anyone want to ask a question about how we got that or push on it at all? Good there? Good? Okay. Then, here is the second one. So looking at the x values, you got to remember, I saw some people talking about subtract by 4 here. Which, if you go from the -2 to -6, is that subtracting by 4? Yes. But if you check the next one, the next x was -1. Is -1 minus 4 that -3? No. So it's not adding or subtracting. We want to recognize that. We need something that's happening the same all the way through. And this is the way I would justify this. What did you say was happening?
Multiply.
Okay, so we are multiply every x by 3. So we want to recognize that is a dilation. What type of dilation?
Horizontal.
So it's a, well, that's the direction. A horizontal, it could either be a,
Stretch or compression.
is that a stretch or a compression?
Straight.
Stretch.
If you multiply the 2 times 3, does that make 2 bigger or smaller? Makes it bigger, right? So that's a stretch. A stretch literally means to make it bigger. So a horizontal stretch by f equals 3. That's my factor. Vertically, what was happening?
It was 4.
Okay, so add 4 to every y.
Man.
So that's going to be a vertical
Translation.
translation by
4.
4. Okay. So y equals 3x cubed plus 4. Anybody want to push back on that or ask a question about that equation?
You need to do the inverse.
Where? Here?
No. The 3.
So that 3?
You need to be 1 divided by.
Can anyone explain why it should be 1 divided by 3?
But it's the multiplicative inverse.
Remember, horizontally, the stretch is by 3. But when I write the equation, I need the inverse. And it's multiplying, so I need the multiplicative inverse. So instead of multiplying by 3, I'm going to multiply by 1/3. What are your questions at this point? So that's how I would justify it. I saw, again, a lot of us were adding 4 along here, looking at the rate of change. Don't do that, or indicating as rate of change. Explain it like this as coming from the parent function. Alright, I'm going to do this very quickly. Make sure you graph at least the parent function and let's say transform function 1. Remember, all I'm doing is graphing the points. So that's 2, 8, 1, 1, 0, 0, -1, -1, and -2, comma, -8.
Miss Kenny, why are we not doing transform functions?
We will not have any like that on the assessment because it's very doable, but it would just take more time and we need to focus on other concepts in this course. Is the best way to do it, or say it. If we had learned these concepts really well in Algebra 1, so I wasn't having to reteach this at least, or the Courtney, then I would probably go into details. Okay, really quickly, I want you to notice this. Every point was translated how far? to the left how much?
4.
4, right? This point right here was to the left how far? 4. So we can see the fact of that translation left 4, remember this transformed function 1, in every single point. On top of that, this was a y value of negative 8, now it's a y value of negative 4? Because what was vertically happening? Oh yeah, you need to go, Sharnavia, don't you? So what was happening to every y value?
You wanna know like what?
No, y value.
Oh. Well, on one time, I don't
It's
know.
Multiplied by 1/2. See how it was vertically compressed? Every single one of these y values was compressed or halved. That's why it went from all the way down here to up. Even this negative 1 is now negative 1/2, so it's compressed vertically. So all those transformations come into play for these different functions. I'm not going to go into all the details, but this is transformed function 2. Do you see how much wider this one is? That green one that I just did? Why is it so much wider?
Cause,
Cause it's multiplied.
About 3.
What was multiplied by 3?
It's stretched right there.
The whole, and remember, not just stretched, it was horizontally stretched by 3. Right? So we want to recognize those details. What are your questions before we continue?
No.
Alright, so make sure that you're paying attention and being attentive to those details because those transformations are showing up. Here is the second packet that I gave you yesterday. As with all things in transformations, what's the first thing you need to do?
identify that.
Identify that parent function. After you identify the parent function, what do you need to do? You need to identify the translations. Yes, you need to write down the parent function. But guys, after you identify the parent function, you write it down. You need to identify the transformations and write those down. Oh look, it's right there. And then use that to write the equation. Now, I need y'all to hear this clearly. I have given you a graphical representation. If you don't see the transformations graphically, is there anything else that you could create to help you see the transformations?
Table.
Don't forget that. It's your choice. I've done them a lot, so I can pretty comfortably get the transformed functions, or the transformations just off the graph. Because, I mean, we should recognize this parent function. Anybody?
Quadratic.
It's quadratic, so what's the equation? Not just x squared,
Why?
or f of x works. X squared, and we would say quadratic. Now if I were to ask you to justify that, why do you know it's quadratic?
The top of
Say that one more time.
the top of the
The shape, the parabola. Remember, the square is something you are claiming, right? You need evidence for why you're saying
Oh, I
squares.
was looking at the evidence from the equation.
Right. But you claimed it was y equals x squared. You would need to say, hey, it's a parabola, so it's a quadratic function. And hopefully we know the parent function graph by now. If you don't, can you again make a table to get that graph?
Yeah.
Yes. But also, if here's an x value of 0, what is 0 squared? 0. Okay, so that point is 0, 0. Look at this x value of 1. What's 1 squared? 1. So when the x is 1, the y is 1. Here's an x value of 2. What's 2 squared? 4. So when the x value is 2, the y value is 4. Negative 1 squared gives me 1, negative 2 squared gives me 4. So, you can make a table, you can just look at the graph to see what transformations were applied. Let's work within our small groups. Miss Courtney and I will be supporting you for the next 30 minutes. This is the last amount of time we will have to practice this before an understanding check tomorrow. Let's get to work.
Wait, let me understand it first.
This, wait, I need this. Yeah.